Okay, in our last section for factoring, we're going to go ahead and we're going to put together all of our different things. So the very first thing we want to keep in mind is the very first thing we do is we look for common factors. Because the more stuff we can take out, the smaller it makes our numbers and it makes it easier to factor. The next thing we look for is one of our special patterns, the difference of squares patterns or the perfect square trinomial pattern. Because if we know those patterns, then it makes it a little bit easier on us. And then from there, we go ahead and we factor using our box method or grouping method. So those are the types of problems we're going to practice now. So the very first thing we do is we look at our problem and we decide, hey, what's my greatest common factor? What can all of these be divided by? And so when I look at them and I'm like, okay, they're all even. So they all can be divided by 2. This can be divided by 5, but the others can't. So it looks like only 2 and 5 go into the 10, so 2 is my greatest common factor. So I pull out that 2 and I divide, so I get 5x squared plus 24x plus 16. And now I go ahead and I use my normal factoring methods because I know that this is not a perfect square, even though this is. So neither of my squares patterns will work. So now I just go to my normal factoring. So I multiply these two. So 5 times 16 gives me 80x squared. I'm going to try and find all the things that multiply to be 80 and add to be a positive number. So that's what I'm going to go for. So there's a 1x and an 80x, a 2x and a 40x. 3 doesn't go, but 4 goes 20 times. And I think I just found it. So here's the one that adds to be 24. So I'm stopping there. And I'm going to go ahead and factor this out now. So 5x squared plus 4x plus 20x plus 16. I find my common factor. Looks like there's only an x. I find my common factor. There's only a 4. So this is x times 5x plus 4. Then I pull out that 4 and I divide, so I get 5x plus 4. There's a 5x plus 4 in common, so I'm going to factor that out. And then I'm left with an x plus 4. Now there's one little dude that I forgot about. I factored out this 2 up here that doesn't stay away. I bring that down to the very end and it just hangs out in the front. I could have brought that down out here, but I didn't want to bog down my information and have a 2 here and then just keep bringing it down with all the other parentheses. So usually I make a little note to myself, hey, there's going to be 2 at the end. And in fact, sometimes I'll go 2 and go like that and then work out my problem and fill in the blanks there. So that way I don't forget about them. Okay, next one. Okay, 4x to the third, 16x squared plus 16x. So it looks like they all have an x, and they all can be divided by 4. So I'm going to factor out a 4x, which means it's going to look like 4x, and now I divide, so I get x squared plus 4x plus 4. And so now I'm ready to factor that inside. And so I could factor it normally, or I can look and say, hey, this is a perfect square and this is a perfect square. This is really x times x, and this is really 2 times 2, and then I can check my middle. Is this really 2 times x times 2? Yep. So this becomes 4x times x plus 2, since this worked. And there's a plus squared. Now, if you didn't want to do that, we can factor normally. So I can go back to this 4x, x squared plus 4x plus 4. And I could circle front and last, multiply it, so I get 4x squared, make my list, 1x, 4x, 2x, 2x. Oh, there we go. That one adds to be this. So now I'm going to put that 4x down here. I'm going to leave room for my answers. So this becomes x squared. And you know what? I'm going to do the box method on this one for those who like the box method. So I'm going to draw my box. Now I have x squared plus 4 plus 2x plus 2x. And I look for those common factors. Oh, Those share an x. Oh, those can both be divided by 2. Oh, these share an x. Oh, these can both be divided by 2. And then I check x times x is x squared. X times 2 is 2x. X times 2 is 2x. 2 times 2 is 4. We're good, which means this is my first polynomial, x plus 2. This is my next polynomial, x plus 2. And there's my answer. Okay, so next one, 2x squared y minus 2y to the third. Okay, so they both have 2's, and they both have y. So I'm going to factor out a 2y, which means now I'm going to have x squared minus y squared. So this is that classic difference of squares pattern. So we're going to go ahead and look. This is really x times x. This is really y times y. And since there's a minus in between, that means it's going to factor into, okay, I'm going to leave that 2y out here, x plus y, and then an x minus y. So that's that difference of squares pattern. There's no middle term. So that means that if these are perfect squares right here, one's going to have a plus, one's going to have a minus, and that's our final answer. Okay. So let's move to our next one. Let's see. I see nothing in common. And there's a perfect square and there's not. So I'm just going to go ahead and I'm going to multiply like normal. So negative 18x squared. I want it to add to be a positive number. So my bigger number is positive. So negative 1x and 18x. Negative 2x and 9x. Negative 3x and 6x, and it looks like there's my winner chicken dinner. So now everything that's circled is going to get written out. So 9x squared minus 3x plus 6x, and then minus 2. Now when we're factoring by grouping, I'm going to look, okay, what's common between these two? 3x. What's common between these two? Positive 2. So now I factor out that 3x and divide, so I get 3x minus 1. I factor out that 2x and divide, so I get 3x minus 1. The 3x minus 1's match, so I factor those out. 3x minus 1. Whatever's left behind is my next factor. 3x plus 2. And there's our answer. Okay, next one. Ooh, we do have stuff in common. They all have a b. I know 2 works. I know 4 works. 6 works. 8 does not. 12. I think 12 is the biggest number. So I'm going to factor out a 12b. And that's going to leave me with b squared plus 4b plus 4. And then we're going to go ahead and factor this out. So now we're going to go ahead and multiply first and last. So 4b squared, which gives me a 1b and a 4b, a 2b and a 2b, and it looks like there's my winner. So now I'm going to go ahead and write down here that 12b. I'm going to give myself my parentheses so I don't forget about that 12b. We're going to factor this out. So b squared plus 2b plus 2b plus 4. Common factor here is b. Common factor here is 2. So let's factor that out. So I divide b and then plus 2. Factor this out and divide b plus 2. And they both have a b plus 2, so I'm going to factor that out, b plus 2, which leaves me with another b plus 2. And so there's our answer. Another way you can write the answer, 12b times b plus 2 squared, because there are 2 of the b plus 2's. Okay, we only have 2 more problems left. 2x to the 4th minus 18. So let's see, they both have a 2, so let's factor out 2. So we'll have 2x to the 4th minus 9. And now it looks like it's a difference of squares pattern, so let's figure out our parts. This is really x squared times x squared. This is really 3 times 3, which means it should factor into x squared plus 3 and x squared minus 3. And so a lot of times what I like to think about is, okay, the square root of this is x squared. The square root of this is 3. Or x squared times x squared gives me x to the 4th. Or 3 times 3 gives me 9. Okay, next one. X to the 3rd plus 4x squared plus 3x plus 12. Holy shnikes. I don't see anything in common, but there's 4 terms. So let's see if we can factor by grouping and see if this works. So let's see, these have an x squared in common. This has a 3 in common. So let's factor that out. X squared gives me an x plus 4. And then we have a plus 3. And then when I divide, I get x plus 4. Nice. Since those match, I'm going to factor that out. X plus 4. Which leaves me with x squared plus 3. And that's our final answer. And so here was our final answer here. And so that's it for today.